Ever wondered how your devices communicate with each other over a network? The secret lies in network protocols. These are a set of rules that determine how data is transmitted and received on a network. These protocols are crucial in ensuring that your devices, from smartphones to laptops to smart fridges, can talk to each other and exchange information in a seamless and efficient manner. There's a veritable alphabet soup of network protocols out there, each with its unique role and function. From TCP that ensures reliable and ordered delivery of data, to IP, which is the backbone for addressing and routing data, to HTTP and HTTPS that are used for transferring web pages and secure communication on the internet, and many others, each protocol has a specific role in facilitating communication and data exchange between devices on a network. Now, let's delve into some of the most commonly used network protocols. First up, we have the Transmission Control Protocol, or TCP. The TCP is akin to a diligent postman. This connection-oriented protocol is responsible for ensuring reliable, ordered delivery of data packets between devices on a network. Picture this: you're sending a message from your computer to a server. TCP takes up the task of breaking your message into smaller, manageable packets of data. These packets are then sent over the network, navigating the vast web of global connections. But here's where TCP truly shines. It doesn't just dump the data packets and hope they reach their destination. No, TCP keeps track of each packet, making sure they all reach their intended destination. And if a packet goes missing, TCP resends it. Once all packets arrive, TCP also helps put them back together in the correct order, ensuring your message is received just as you intended. TCP ensures that data sent over the network reaches its destination without errors and in the correct order. Next, we have the Internet Protocol, or IP. Imagine IP as the postmaster of the digital world. It takes on the crucial role of addressing and routing packets of data, ensuring they travel across networks and arrive at the correct destination. It's like sending a letter through the post. The IP is the system that sorts and delivers your data to the right address. There are two versions of IP in use today: IPv4 and IPv6. IPv4, the older version, uses a system of 4 sets of numbers, but due to the exponential growth of the internet, we started running out of unique addresses. That's when IPv6 came into the picture, with a much larger range of possible addresses, ensuring that we won't run out anytime soon. In essence, IP is the foundational protocol for sending data packets across networks. It's what helps your email reach your friend halfway across the globe, or that cute cat video to load on your screen. It's the unsung hero of the digital world. Let's move on to some other important network protocols: HTTP and HTTPS, FTP, and SMTP, POPI, IMAP. These are the building blocks of our daily internet activities, from browsing the web to sending emails. HTTP, or Hypertext Transfer Protocol, is the protocol used for transferring web pages and related files over the internet. When you type a URL into your web browser, HTTP is the protocol that fetches the page from the server and displays it on your screen. However, HTTP is not secure, meaning the data transferred can be intercepted. That's where HTTPS, or HTTP Secure, steps in. It's essentially HTTP but with added security. HTTPS encrypts the data transferred between your browser and the server, making it harder for anyone to eavesdrop on your online activities. So, when you're doing online banking or shopping, you'll want to ensure the website uses HTTPS. Next up is FTP, or File Transfer Protocol. This is the standard network protocol used for transferring files from one host to another over a TCP-based network. FTP is commonly used for uploading files to a server, like when you're updating your website. Now let's talk about emails. SMTP, or Simple Mail Transfer Protocol, is the protocol responsible for sending emails. When you hit send on an email, it's SMTP that gets your message from your device to the recipient's email server. But what about when you're receiving emails? That's where POP and IMAP come in. These stand for Post Office Protocol and Internet Message Access Protocol. These protocols are used by your email client, like Outlook or Gmail, to retrieve emails from the server so you can read them. These protocols play crucial roles in our day-to-day internet activities. They ensure that we can browse securely, transfer files, and send and receive emails. And they do all this behind the scenes, without us having to worry about the technicalities. It's a testament to the sophistication of our digital world. Now, let's look at DNS, SSH, and BGP. DNS, or Domain Name System, is a bit like a phone book for the internet. It translates human-friendly domain names like google.com into the numerical IP addresses that computers use to identify each other. This allows us to browse the web and send emails without having to remember a string of numbers for each website or service we use. DNS is a critical part of the internet infrastructure, transforming the World Wide Web into an easy-to-use, universally accessible space. Next up is SSH, which stands for Secure Shell. Picture this: you're a network engineer and you need to access a server that's halfway across the world. You'd need a secure way to log in remotely, right? That's where SSH comes in. It provides a cryptographic secure channel for remote login, file transfers, and command execution, even over insecure networks. SSH is like a secure tunnel through the wild west of the internet, protecting your data from would-be bandits and ensuring it gets safely to its destination. Finally, we have BGP, or Border Gateway Protocol. BGP is the Postmaster General of the Internet, directing traffic between different networks. It's a protocol used by Internet routers to share routing information, helping them to dynamically choose the best path for data transmission. BGP is what keeps the Internet running smoothly, ensuring that your data packets don't get lost in the vast expanse of the digital universe. So there you have it. DNS, transforming numerical IP addresses into human-friendly domain names. SSH, providing secure channels for remote access and data transfer. And BGP, directing internet traffic to ensure efficient data transmission. These protocols are the unsung heroes of the internet, working behind the scenes to make our online experiences seamless and secure. These protocols are essential for secure and efficient internet operation. Last but not least, let's discuss DHCP, SNMP, and the TCPIP suite, starting with the Dynamic Host Configuration Protocol, or DHCP for short. This is a network management protocol that plays a crucial role in our day-to-day online activities. Think about it. Every device that connects to a network needs an IP address. But who assigns these addresses? That's where DHCP steps in. It automatically assigns IP addresses and other network configuration parameters to devices on a network. So whether you're connecting your smartphone to your home Wi-Fi or your laptop to a public hotspot, DHCP is working behind the scenes to ensure your device can communicate on the network. Next, we have the Simple Network Management Protocol, also known as SNMP. Now, SNMP is a bit like a remote control for network devices. It's used to manage and monitor network devices and their functions from a central location. This could be anything from checking the status of a router to adjusting the bandwidth on a network switch. SNMP provides network administrators with the tools they need to keep the network running smoothly and efficiently. Finally, we come to the TCP/IP suite. This is a family of protocols that includes TCP, IP, and others, like the User Datagram Protocol, or UDP. These protocols form the backbone of the Internet and many local and wide area networks. The TCP/IP suite is like the rulebook for network communication. It dictates how data should be packaged, addressed, transmitted, routed, and received at the destination. Without the TCP/IP suite, the Internet as we know it would simply not exist. So there you have it, DHCP, SNMP, and the TCP/IP suite. Three essential protocols that keep our networks running and our devices connected. They ensure seamless connectivity and reliable data transmission across different types of networks. These protocols may operate behind the scenes, but their impact on our digital lives is absolutely foundational. So, we've covered a lot today about network protocols, from the transmission control protocol that ensures reliable and ordered data delivery to the Internet protocol that routes packets of data to their correct destination. We've ventured into the realms of HTTP and HTTPS, which transfer web pages and files securely, and FTP, which facilitates file transfers over a TCP-based network. We've discussed email-related protocols like SMTP, POP, and IMAP. the domain name system that translates human-readable domain names into IP addresses, and Secure Shell for secure remote login. We've also touched on the Border Gateway Protocol for exchanging routing information, DHCP for automatic IP address assignment, SNMP for remote network management, and the TCPIP suite that forms the backbone of the Internet and many networks. Remember, while the world of network protocols may seem complex, each protocol has a specific role in ensuring our devices can communicate effectively over a network.